let's see the symbol. As we all know, the common AND gate is represented as this is A, this is B, and this is Y, where Y is equal to A dot B. Now, how do we obtain this A dot B? We can directly use the NMOS, PMOS and design a schematic diagram, or the other way to represent this Y is A dot B bar whole bar, which is NAND. You can see this A dot B bar is NAND plus NOT to prevent this whole bar. Now let's see the schematic of this A dot B. How do we represent is a dot operation in terms of NMOS and PMOS? If it's a dot operation, then we all know that we have to place the NMOS in series and the PMOS in parallel. So the obtained output will be A dot B whole bar. If we implement this one, if we place the NMOS in series and the PMOS in parallel, then certainly we will obtain the output A dot B bar. Then we have to place another inverter, in order to obtain a final output, that is A dot B, the AND gate. Now the schematic diagram is done in two ways. The schematic is done in two ways. One is the normal schematic, where the NMOS and PMOS are placed in this way. Then correspondingly over here, somewhat like this. Then we have the twisted schematic as the twisted form, where we will place it as like this. We will twist the PMOS and the NMOS and place it so that this becomes very convenient for us to draw the layout. We'll place all the PMOS in one place and we will place all the NMOS in one place. This is the PMOS and this is the NMOS. Now we will see how to draw the schematic of a 2-input AND gate. with normal placing the NMOS and PMOS. Let's term it as schematic 1. This is our schematic 1. Now A dot B means the NMOS is in series and the PMOS in parallel. Let me place the PMOS first. This is my VDD line. This is my first PMOS. This is another PMOS. And these two PMOS are in parallel. Next, the NMOS are in series. This is grounded. Now this is my A input. This is my A input and this is my input B. Let me term it. This is input A and this is my input B. Okay. Now this is my PMOS 1. This is my PMOS 2. This is my NMOS 1. This is my NMOS 2. Now let us name the sources and drains. This is the VDD. We all know that all the sources of the PMOS are connected to VDD. The sources of NMOS are connected to ground. So this is source of P1. This is source of P2. This is gate of P1. This is gate of P2. This is drain of P1 and this is drain of P2. Okay. Now, so we can see that this is the common drain terminal and the output is always obtained from the drain, the connection, the terminal from the PMOS drain and the NMOS drain. So this is drain of N1. This is gate of N1. This is the source of N1. And again, we know the sources of NMOS are connected to ground. So this is source of N2. This is the gate of N2 and this is the drain of N2. Now the obtained output from here, this is the output terminal. Since this is one drain, this is drain of NMOS, this is drain terminal of PMOS. So the obtained output will be A dot B bar. The obtained output is A dot B bar. Okay. Now, in order to obtain A dot B, we have to place the inverter over here. Now this is the VDD line. Let me make this common VDD for the inverter and the NAND gate. So place the PMOS. This is the NMOS. Okay, we're drawing the inverter. Now this is connected to ground. The way we had the common VDD, we can also place a common ground line also. Now we have to connect the output to this. Output will act as input to this inverter. Okay, now this is our P3 and this is our NMOS 3. Now we will write the source and drain terminals. Why we need to mention the source and drain terminals? So that it is very convenient for you to draw the layout correspondingly. Now this is the source terminal of P3, this is the gate of P3, and this is the drain terminal of P3. This is again the output is obtained from the uh, from the point of connection of drain of PMOS and drain of NMOS. So this is the terminal, this is drain of N3, gate of N3 and source of N3. Now this is the output terminal. So the obtained output is A dot B bar whole bar, that is equal to A dot B. This is our 2 input AND gate. So this is our 2 input AND gate. Now can you just directly draw the layout from this kind of schematic? Yes, we can draw, but it will be very unorganized. So we can draw the twisted form of diagram for this AND gate. Okay, so now this is our this is our NAND, this is our NOT. So this NAND and NOT will give to 2 input AND. Okay, now let's see the twisted diagram of a 2 input AND gate, which is very convenient in order to draw the layout. So let us give the heading schematic 2. This is nothing difficult and it is nothing new. We just need to twist the NMOS and PMOS. Okay. Now in order to draw this twisted diagram, we have to keep in mind all the NMOS are have to be placed at one side in this way. All the NMOS are to be placed like this is the PMOS, okay, and this is the all the NMOS, all the PMOS present and all the NMOS, all PMOS on one side, all NMOS on one side. This is PMOS 1, PMOS 2. Similarly, we have to place NMOS 1 and NMOS 2. Okay. Another, we have the inverter part. So 1 PMOS and it should be just below this one. Just below the PMOS. So this is my PMOS 1, PMOS 2, NMOS 1 and NMOS 2. This is P3 and this is N3. So now just mention the source and the drains, just the source and the drains, so that it's convenient for you to convert this schematic to your layout. So you can say this is the gate, so these two are the gate, so this is gate, this is gate. Similarly over here, gate terminals. Next, the PMOS were in parallel and the sources were connected to VDD. So this is source, this is source. The common drain was connected to the drain of first NMOS. We can say the, okay, let me write this is N, okay, this is N1, this is N2. So this was connected to one of the NMOS. So this is the drain, this is the drain terminal, and this is the source, this is the drain, this is again the source. Similarly, source, drain, this is the drain, this is the source. Now we can connect this gate to this gate, gate to gate. Then the two sources were shorted, so short these two sources, connect, and then this is connected to VDD. This source is also connected to VDD. Okay. Similarly, the common drain is connected to the drain. Now these two drains are also shorted, and this is connected to ground. Similarly, this source is also connected to ground. Now this is the output terminal, which is, this is our A, input A, this is input B. So the output obtained will be A dot B bar. This output will act as the input to the inverter, and the output will be obtained from here, which is represented as Y A dot B bar whole bar, that is equal to A dot B. And okay, this is the twisted diagram. Now we have to convert this to exactly, we have to convert this to the layout form. This is the twisted form. Okay, now I will convert this to the corresponding layout. How will you draw the layout? Now you have to keep in mind, let's go to the previous page. We have to keep in mind to place all the source drain with metal layer and the gate with polysilicon layer. We all know about this, and then we have to place the corresponding contacts. Okay, now let's draw the layout from the twisted form. Layout of twisted form. Layout of the twisted form. Okay, how will you draw the layout? We have to first make the, okay, so first, for the PMOS, you have to keep in mind we use the P diffusion layer, and in order to place the N substrate, we have the N well. For PMOS, there is N well. So this is the N well of the NAND portion, and this is the N well for the inverter. Now the N well is black in color. This is the N well, and the P diffusion is brown in color. P diffusion layer is placed. Now similarly the P diffusion layer for the inverter. P diffusion. Okay, now this is our PMOS. Now in order to place the NMOS, in order to draw the layers for NMOS, it's green in color. The N diffusion layer is green in color. Okay, now this is the N diffusion layer. Now we have to first connect the of source of both the PMOS to VDD. So this is my source part, this is my source part, this is the common drain part, this is the gate, this is the gate. This is the common drain, means drain for both. So you can see source, gate, drain, source, gate, drain. So this is one PMOS. So the sources are connected to VDD. So how it is connected? It is connected by the metal. This is was metal layer. We can directly short it. Okay. Now after this, on connection with the VDD, this is VDD, we can say this P diffusion layer, above the P diffusion layer we have placed the metal layer. So how will they come in contact? We have to place a metal contact. So placed a metal contact, here also metal contact. Now we know the VDD, this is similarly the, so let us first mention all the sources and drains. This is the source, this is the drain, this is the gate, this is the drain, gate and source. Similarly we have the source, gate, drain and source at one terminal, then gate and the drain terminal. Okay, now let's finish this part. Now the source of this PMOS has to be connected to the metal layer. Okay. Similarly, let's extend this. We know the source of the inverter is also connected to ground. Let's extend this. Okay. Now this is the ground. Similarly, this source is connected here. Now let's place the contact. Similarly, a contact over here and a contact over here. Okay. Now the gates have to be shorted. The gates are shorted by placing a poly layer. Okay. Now these are the two drains, and again the two poly. Similarly, this is poly layer. Now let's name it, this is input A and this is input B. This is the input of the inverter. Now we have to place the output of the NAND part. So the output of the NAND part is placed with metal layer. So the common drain is connected to the drain of the PMOS. Okay, now this is the output part. These two are also connected. This is the output part. This is our metal. Okay, now again we have to place a contact. So certainly there's a question, what kind of contacts are placed? This is a N substrate contact, and these are the P substrate contacts. These contacts are this is the p diffusion contact, and this is the n diffusion contact. Now, similarly, some more contacts are placed over here in the VDD and ground. This is the P substrate contact. Similarly, this one is the N substrate contact. Okay, now you can see the output of the NAND is this. This is A dot B bar. This has to be connected to the input. Now certainly there will be an overlapping. This is the overlapping portion. How will this poly and metal be in contact? We know we cannot link interlayers. So we have to place a contact. It's a poly contact and it's usually purple in color. So let me this is the poly contact. This is the poly contact and the obtained output is this Y. Now this is the layout of the twisted form of this two input AND gate. Similarly, we can draw the layout directly from the normal form of schematic. Now we will see layout from the normal schematic, that is not in the twisted form. Now this is going to be a very big diagram, so let me clear this and we'll start from the beginning. We have two NMOS So draw to anvil. Then to P division. So this is to PMOS. Okay. Similarly, this is also connected to VDD. Let me place the contacts. Okay. Now we have to create the PMOS. We make a PMOS since the NMOS, this is the NMOS, the two NMOS will be in series, so I have taken only one, and since the two PMOS were in parallel, so I have taken two separate. Now remember, this is our PMOS 1, this is our PMOS 2. Then okay, before that let's make the inputs and the outputs. So there will be two inputs here. This is input 1 and this is input 2. Okay, so we'll short this, we'll short this. Okay, now the two inputs are shorted. Let's say this is B and this is A. Okay, the two inputs are shorted now. Now we have to short these two drain, and this is the drain, this is the drain terminal, this is the drain terminal, this is the drain, this is source, 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 drain, source. These are the gates. Okay, now we have to short these three drains. So let's short it. Okay, place two contacts and again we have to short these two. Okay, now we have to make an inverter. and this is N-well, this is P diffusion. Okay, this is the N diffusion. So similarly, this is now. This is connected to VDD, and this is connected to ground. So these two sources are connected to ground. This is ground. This is one contact. This is another contact. Okay, and these two are shorted. Since these two are the drain terminals, so this is the output. Now this is the common drain that has to be connected to the input. So I need to place a contact. So here there will be a contact. So the contact will be certainly purple in color. So there will be a contact over here. Now this is the whole layout of the normal form of the AND gate. So we can label it. This is the metal layer. You can see this exactly represents, like I can show you here. We had the PMOS in parallel, which was connected to VDD. This PMOS is this one P1, this PMOS is this P2. Okay, now it was connected to two NMOS, then they were shorted, and this was the common output. As these two are shorted, common output, this is given to ground. From here VDD, this is ground. You can see exactly this is represented. We forgot a contact. Same VDD, common VDD. Then this is the common ground. This is the source. This is the gate. This is the drain. This is the drain, gate, and source. All the sources are connected to VDD. the earth sources of the NMOS are connected to ground. You can see exactly this schematic is represented in the layout.